Hey, how's it going? Welcome to the At Odds podcast. I'm your host, Ricky. You got a very special episode today. We want to talk about DeepSeek and what's been happening in the world of AI. It is interesting, to say the least, and there's a lot that is at play. So let's figure out some of the details. I'm joined by my resident expert, Alex from Ticker Symbol U. He has an amazing channel. He covers this stuff on the daily. So really excited to have you, Alex. Thank you for joining us. And let's just get right into it.
Sure, happy to be here, and I'm excited to talk about everything DeepSeek.
This video is brought to you by Delete Me. Clearly, I woke up to like my X feed just blasted with, NVIDIA stock is down $500 billion, about 20%, and other companies like followed suit as well. A lot of semiconductor companies, the companies that you cover. So let's just start with how big of a deal is DeepSeek and why is it a big deal?
So DeepSeek is a very big deal. It appears that everything that's in the technical papers, for example, is true. There are obviously some questions around the actual cost of training DeepSeek. So let me back up and I guess frame the problem, right? DeepSeek is a large language model that came out and it topped the benchmarks or came close to topping all of the benchmarks. When I say benchmarks, I mean like math tests, science tests, literacy tests, a wide variety of academic and coding related benchmarks. But what happened was it took a fraction of the price to train. And its API, which they've released, it's an open source model with an API that you can plug into, is also a fraction of the price. So it took about $5.6 million to train, as opposed to the 200-ish million it took to train GPT-4, so about 2.5% of the training cost. And as a result, the API costs are about 20 to 30 times lower than OpenAI's API costs, right? So just comparing apples to apples, both on the training side and on the inference side. And they perform similarly. So you can imagine this is a giant step function in compute per dollar. And it didn't happen from a Western AI lab. This isn't Google DeepMind. This isn't OpenAI. This is a Chinese startup with less than 200 employees, less than $10 million, far less than $10 million. And they open sourced it. So you can see everything. There's nothing hidden. They kept back some of the training data, but other than that, you can see exactly what's going on in the code. They released a couple papers that I went through in my latest video. It's very legit. And why it's such a big deal is the question is, well, if you can train it on $5.6 million, why are we spending billions, if not trillions collectively on NVIDIA's GPUs, and all of this hardware and networking infrastructure, the Stargate program, right? $500 billion budget. There's a big discrepancy between the apparent cost of frontier models and how much America is spending on AI infrastructure.
There's also an implication for energy usage, right? I mean, one of the things that I've covered in the past is AI's unimaginable appetite for electricity and how, some of the electricity demand is going to absolutely go crazy. We've got companies buying up old nuclear power plants, getting them back online. Google's building a geothermal plant. I mean, it's pretty wild. So correct me if I'm wrong, but this would not only impact the cost, like the consumer in terms of the cost for API usage, but also potentially the amount of electricity and energy we would need in the future for training these kinds of LLMs, right?
I'm curious, when you say that, do you think energy usage is going to go down, or do you think it's going to go up because of this breakthrough?
So this gets into something you brought up in your video. By the way, I'm going to put a link in a card to Alex's video that he just shared today, which was absolutely brilliant. Must watch. We'll put a link to it. You got to go check it out after this one. But yeah, in that video, you mentioned Jevons paradox, which is you bring the price of something down and people think, oh, okay, cool, we're going to save money. My favorite example is traffic. The argument is always, if we widen this freeway and add 2 more lanes, that'll solve traffic. And every time people try that, historically, traffic goes up. And it's because other people go, sweet, now the 405 has 7 lanes. I'm going to drive my car today instead of something else, right? So a lot of the topics we cover are counterintuitive or not immediately obvious. You know what's really not obvious? How exposed your personal information is online. It's why I've been a member of our sponsor, Delete Me, for 2 years now. Delete Me is a hands-free subscription service that'll remove all your personal information that's being sold online. And it's not just a one-time scan. Just look at all these listings that have been reviewed each quarter and how the amount of exposed data is going down over time. I just got my 8th quarterly report, and Delete Me has scanned over 2,300 listings, and it's just amazing to see how the amount of data being exposed just keeps going down over time. And remember, Delete Me isn't just for you. There's family plans so you can protect your entire family and keep all of their data safe. Because we all have a lot on our minds, and your privacy probably doesn't come up very often. It's why I let Delete Me stay vigilant and do all the work so I don't have to think about it. Have you ever heard the expression, if something is free, you're the product being sold? So join Delete Me and save 20% on all plans with my code Ricky. Links in the description. Huge thanks to Delete Me and you. Now back to the show.
Right.
It's one of those things where it's a paradox for that reason. And I'm sure what you're hinting at is if we make this so easy, that means that everyone, even small companies, individuals will start using it, and collectively the energy usage is probably going to go up regardless. Is that fair to say?
Yeah, I think so. And so really what's happening is on two fronts. What you just said, I believe personally, so not an objective fact, but my opinion just sitting here as sort of an informed investor and like somebody who's in the know on this stuff in general, it's going to go up in two different ways. The first way is what you just said, where now it lowers the barrier of entry. You know, people who weren't going to pay $20 a month or $200 a month or whatever for OpenAI's API or just like using their subscription might pay $2 a month to do the same thing on DeepSeek, for example, right? So that's the inference case. But the training case, what tends to happen is data centers tend to be power limited. They tend to be chip, footprint, and power limited. Those are really the three constraints. They already have a power budget. They already have their chips, and they're constantly building out that capability. They're not about to ramp down their power. They're about to get way more compute for the power they're already spending. So in my opinion, when things become 25 times cheaper, my dollar goes further. So what's actually going to happen is now I'm much more happy to invest in more power, more chips, more GPUs, more infrastructure, because I'm getting so much more bang for my buck today than I did before the big DeepSeek breakthroughs.
What are some examples of what DeepSeek has done that are so revolutionary? And are they revolutionary?
Yeah, so let's separate a little bit of like what's still a grain of salt from what's in the technical papers and seems to be objectively true, right? One of the big grain of salt items that we should mention is it's not clear where the training costs, that $5.6 million, starts and ends. For example, all the research and development that went into building the model and figuring out how to do this for $5.6 million is excluded from those costs. And that's like a big asterisk on those cost numbers. There's also some like export controls questions, like did they really use NVIDIA H800 chips, which are the sort of slowed down versions of NVIDIA's Hopper H100 chips to get around export controls, or did they actually have access to like the full H100 chips, right? So all that I'm just going to push to the side and not talk about because the jury is still out on those things. What the jury appears not to be out on is the actual, I'll call some of them real breakthroughs because they are, and other real innovations that aren't necessarily breakthroughs, but are like, once you see it, you're like, this is so obvious, I wonder why we haven't been doing it. And the answer to all of the obvious why haven't we been doing it is we've just been throwing money at the problem at the West, right? I'm going to botch some of the names of like the actual techniques they used, unless you want me to like stop and reread the whole technical paper, but we're just going to go through it chunk by chunk, right? So one of the big focuses of DeepSeek, both V3, which is like the underlying model, and R1, which is like the reasoning engine that sits on top of the model, is memory management. So they played a few very clever tricks, very clever mathematical tricks that end up working very well to limit the amount of memory that it takes to train the model and use the model. So that's training and inference. Why is that important? Because the limiting factor in how many GPUs you need in parallel to run these things is memory. It's like the memory of the GPU is the bottleneck. So you need many, many more GPUs to access the memory. You link them all together to keep the problem coherent, send them to all these GPUs, spit out the answers, recombobulate the answers, and the whole answer is like what you get out, right? One of the things that they did was they decided to use variable floating point numbers instead of 32-bit floating point numbers, right? So that's just a fancy way of saying they're sacrificing some numerical precision to have every number take up much, 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 much less memory, right? So they're using FP8 instead of FP32, And because of that, they have to do some extra math on each number to store bigger numbers than like 2 to the eighth, right? Which I think is like 256. So we actually have that hardware here already. The Blackwell infrastructure, and I believe even Hopper can support variable floating point calculations. It's not locked into FP32. Jensen has talked about going all the way down to FP4, so just 2 to the 4. And why that's important is to support these exact kind of techniques. So this isn't something that NVIDIA wasn't prepared for. It's something that Western AI labs just haven't really been doing. Of course, we want to use the most precise numbers. We want the most precise weights and the most precise answers and whatever. And so because these Chinese labs, supposedly don't have access to these high-level chips, they have to start innovating on how much memory they have to take.
We both have backgrounds in software, so it's interesting to think about this. But like, for example, just as a little bit of context, our main like Blender rendering machine that we use for 3D animations and stuff has 256 gigs of RAM for the CPU. But for GPUs, just the nature of the parallel processes and how they work and why they're so good at what they do, they normally have their own dedicated onboard RAM. And so we have a RTX 4090. The 5090 comes out, I think, in like 2 days. But until that comes out, I'm not sure how much RAM that will have. But our 4090 has 24 gigs of RAM. So if we want to model something or make a 3D scene, that's our limitation. If we're going to do GPU-based rendering, which you want to do, our limit is 24 gigs of
VRAM,
of VRAM, right? So 256 on the CPU side, 24, right? So at 1/10 of the available RAM. So any little bit that you can optimize memory allocations goes a long way. And a really quick anecdote before I forget. I used to work on flight controls for the old legacy F-18. And this was like punch card days, right? And we had kilobytes of storage. And so if it was just a switch position, all you need is 1 bit for that. So in one 8-bit number, you'd have to decode it and then figure out, oh, it's the 3rd bit. Okay, this valve was on. So we could store 8 values in one 8-bit number. That's what we used to do. The F-35, the latest generation, has 32-bit floating precision integers and just a ton of wasted space. Why? Because space has become pretty cheap. Like if you want to record a whole flight, what might have been 500 kilobytes in a F-18 Legacy Hornet, now it might be 3 gigabytes. But that's okay because our servers can store 3 gigabytes. It's not a big deal. But when you kind of go reverse engineer it a little bit, we're kind of going backwards to a time when we treated bits as very valuable things and brilliant. I mean, I asked this question to you before we started. How have we not thought about this here in the West? Like, why is OpenAI, how's Llama not using this, right?
Yeah.
It's interesting.
And the answer is exactly what you just said. It's because space is actually relatively cheap. It's easier to develop an algorithm that only focuses on one kind of number and just build the infrastructure to support that. And if that costs a lot of money, well, investors will come in and pay for it because ideally this will pay for itself with dividends, in the future, right? Another way that they save memory is they actually compress all of their numbers first, and all of the vectors and all of the values that they use and store, and then they only feed it to the model post compression. So the model is able to read compressed values. In my video, I go through an example where you compress an image. I'm sure everyone has done this at some point, where you throw an image in Paint, you save it, then you look at the image and it's way worse. It takes up way less memory, it's way smaller, but it also looks like way grainier, there's artifacts, and you're like, what's going on? What happened is Paint compressed your image, but in throwing away some of that data, it actually threw away some of the data responsible for the fidelity of the image, right? What DeepSeek has done is it says, well, we can throw out X% of this data, the percent that affects the parameters that we care about the least, and in doing so, save a ton of space, which again saves a ton of memory, which again means using less GPUs overall, while retaining most of the accuracy of the model. And so again, they play some math tricks to make sure that accuracy is very high. They are very smart about what they throw away versus what they keep. But this has an added benefit. So when you throw away the noisy part of the data and you feed only the high signal part of the data into the model is trained to understand only really high signal stuff. So you actually get 2 benefits out of this. The first being you save on memory, and the second is the model is extremely performant because it's really good at picking out the actual tokens that matter, when you feed it new data that's uncompressed, whether you choose to compress it or not, it's already kind of looking for the most impactful data to inference on. So that's actually really clever and really interesting. And by the way, this is an open source model, right? So we are going to start seeing Western AI labs take all of these techniques and use them. Absolutely. Yeah,
Very interesting.
if you're talking about a picture of a bridge in the sky, just to your example, the model probably doesn't care about those different gradients of blue. It cares about the boundary between the bridge and the background. It might care about recognizing what kind of bridge it is. It might be looking at the edges of the bridge to be like, oh, this is a suspension bridge versus some other flat concrete bridge. I don't know the names of any bridges, but like, the idea there is what's important to the algorithm isn't the beauty of the picture. It's the data that separates object one from object two. In this case, the bridge from the background, the bridge from the sky, whatever. So you could almost feed it a black and white picture of a bridge if the color information isn't that useful. That's going to be a much smaller image that's going to give you a similar result to like taking a great, beautiful 50 megabyte picture, 100, 200 megabyte picture of a bridge and feeding it into the same model. The model's not actually caring about all that. So being able to compress first and look at the compressed version of the image saves a ton of memory without lowering the quality of the performance very much. So you're trading a lot of memory saved for just a little bit of precision again.
In the case of memory, for computers, the trade-off is always like CPU task, like how much CPU utilization you have or computing power you need, versus memory, right? So, like for example, when we watch a Netflix stream, that's been compressed. Maybe it's like AV1, some kind of a codec, maybe HEVC, one of the higher compression ones. And so the higher the compression, the lower the bandwidth, the less internet you need, but you need more CPU power to be able to handle that. So as computers have gotten better, an Apple TV for $100 has hardware decoders and all this stuff, we're able to, increase that game. But that's ultimately the kind of the trade-off.
The magic of like their data pipeline is it's all operating on compressed data. Like it understands how to read compressed data, and then it only decompresses things like as part of the output back to the user is my understanding. So it's like, you have an image, you feed it, let's say an image is part of like the model. I'm pretty sure that this is just a large language model. So we're using images in this example, but what's really happening is it's taking in a bunch of text, compressing it, doing everything in that compressed space, that lower dimension, compressed, much less memory usage space, and then uncompressing the final output to return it to the user so they can read it in like, tokens that are words in English. You know what I mean? As opposed to compressed values and weird integers and stuff.
Walk us through for people who know what that is. What is a token?
The real answer is like actually technical and complicated, but you can almost think of a token as like 2/3 of a word. Computers think in tokens, people think in their native language. There's like a lot of stuff going on in what makes a token separate from a word. But essentially, when we say tokens, if you replace the word tokens with words, you're not far off. So in an image recognition algorithm, a token would be a pixel. In a video algorithm, it's still a pixel, but it's a pixel like in space and understanding which frame it's a part of. So a token is really like the basic unit of whatever you're kind of talking about.
Okay, so we've talked a little bit about some of the memory optimizations. What else did you learn from the papers?
One of the really interesting things that's not just like a math trick, it's more of like an architecture, is this idea of a mixture of experts model. In most models that we have talked about so far, they're big, right? They have billions, if not trillions of parameters. They're one big model that's really good at like everything. But that's not really how like humanity works, right? So I'm an AI expert. I really suck at cooking, right? I'm not really good at basketball. There's like a whole bunch of things I'm terrible at. I would be considered an expert in one thing and pretty useless at a lot of other things. The DeepSeek model kind of works the same way. It's not one big model that's trained to be really good at everything. It's actually what's called a mixture of experts. So when you have a math problem, it turns on the math expert in the model. When you have a linguistics problem, it turns on a different expert. When you have a biology problem, it actually turns on a different expert. So what happens is there's an overarching model that manages like the whole process, understands the prompt, and then what it can do is if its general knowledge doesn't cover the problem inside the prompt. Let's say like a PhD math model, if you give it a fluid dynamics problem, it's going to be like, great, this is out of scope for me. I'm going to kick it over to this model. This model only turns on for that. So otherwise it's not taking any memory, going back to the memory management thing. And then I'm going to take its output and then keep going once I'm like back in the realm of the general part of the prompt. So some of the innovations that DeepSeek brings to the table is around how do I send information to the submodel and get it back in a lossless way. So in a way that doesn't degrade my performance during the transfer steps to and from the submodel, interpreting its output correctly and not hallucinating, so on and so forth. So like managing these sub-expert models is its own like body of knowledge and body of innovation that like DeepSeek really does bring to the table in a public open source way. It's not that they're the first model to do this mixture of experts thing, but they are the first model in my understanding that's open sourced it and showed how it all works. The big innovation, like the holy grail innovation that I think we should spend some time on, it's hard to talk about because it's not built into the model. It's an emergent property of the model. So let's take a step back and talk about what that actually means. The way AI models work is they are trying to do something that maximizes some function, which is just a fancy way of saying you tell this AI, hey, here's what like a really great answer looks like. You get a score based on how close your answer looks like this perfect answer, and I want you to maximize your score. Your goal is to always have a high score, right? What these guys have done, what the DeepSeek developers have done, is they have formulated the game for DeepSeek in a way where it naturally evolved its thought process. It naturally evolved the behavior of breaking a problem down into steps, solving problems steps by steps, deciding when to ask an expert, deciding when to think longer about a problem and spend more time, resources, tokens on harder problems. I just want to be super clear about why this is a breakthrough. Nobody programmed it to do that. That behavior emerged as a function of the reward functions they set for the AI model. So they just described the game, and the model naturally said, hey, to play this game at a high level, to constantly get a high score, I need to, as the model, break problems down into parts, spend more time thinking about harder parts of the problem, ask experts when I don't know the answer. That's a holy grail, because programming all of that logic is humanly impossible. It's an unbound set of constraints. You know what I mean? It's like you're trying to describe in a programming language the essence of human thought. But to have an AI naturally evolve, naturally display those tendencies just as a function of, hey, this is the best way to organically solve this problem, that's what makes it the holy grail.
So we're both small business owners. We run YouTube channels. We have employees. It's the difference between like if you can find an employee who, when you tell him exactly what to do, he can do it. That's good. That's good.
Yeah.
But you find that guy who you're like, dude, I need to get our views up on YouTube, and he goes and just kind of starts to create the parameters of what to look for, comes up with strategies, looks for what to look for. That's like the A+ employee, right?
Yeah, that's exactly right. So
that's why it's a holy grail.
Yeah, this DeepSeek model like shows initiative. You know what I mean? It's like, oh, don't worry.
Yeah.
You tell me the problem. I got it. I'll go figure out how I'm going to solve this problem instead of you telling me. That's right. That's like a pretty good analogy, actually. It appears that it was trained on ChatGPT outputs. Like, for example, when you ask it, hey, what are you? What model are you? It'll say, oh, I'm ChatGPT by OpenAI sometimes. So that, I think, terms of service violations and stuff like that aside, I think that's really interesting, because what these open source models, I think there's going to be a really interesting trend where they're never at the frontier, right? So this model, if what I just said is true, this model can't exist without ChatGPT, right? This
Right.
model is trained on the outputs of the things that came before it. It's literally standing on the shoulders of giants. What it does do, in effect, is raise the floor, because any model that's worse than DeepSeek now is unacceptable, right? Like, all you have to do is spend $5 million, which, just to be clear, there are several New York City apartments that cost more than that, right?
Yeah.
And you have a next to frontier model. right? So you're always piggybacking, and what you're doing is you're closing the distance between what the worst acceptable model is and what the highest costing frontier model is, right? There are going to be times where you want the frontier. DeepSeek is not like going to be this one size fits all solution. For example, if you're talking about cancer screenings, you probably can't accept a 1% error rate, 99% accurate, 1% error rate, right? You probably need something like Six Sigma or 6 9s or whatever the right answer is. So there are going to be cases where you're like, I have to pay for the best OpenAI o1, o3, the best model. I can't afford to take the risk, and the liability associated with that risk and use something like DeepSeek. I think there's going to be a whole big discussion around what is the state of the art? Is the state of the art what is the best model, period? Or is it the best model that everyone can access like DeepSeek? Or when you train one model on the outputs of another, which model really is the state of the art in the first place? If you remember, like last year, there was this big scandal around what was OpenAI's Sora trained on. YouTube videos, videos that it wasn't supposed to, blah, blah, blah. Who gets the rights for that data? Training on Reddit, buying Reddit or like licensing data from Reddit, versus scraping it illegally. I think we're going to get into a similar discussion about is it legitimate to train a model on the outputs of another model, right? So the jury's still out on that one. Obviously, it results in really high performance, but what kind of quirks does it pick up along the way? Where are its flaws? Which model do you attribute the flaws to? How do you fix those flaws if they're inherent to the output of the trained model versus the training model? So this is going to raise like a whole bunch of questions that nobody's really asking yet, because we're still all in this phase of like, wow,
Yeah.
it's cheap. That's what everyone cares about now. But like all of these like training techniques, I think are going to be a topic of like serious debate and discussion in the AI community.
This kind of ties back to Jevon's paradox. The price of compute has plummeted, right? I mean, when we were kids, I had this Pentium 1. My parents paid, thousands of dollars for. Today, you can get a Chromebook for a couple $100.
Yeah.
But as that's happened, for me personally, I still use like a $4,000 MacBook Pro. I mean, there's cheap computers out there, and I'm sure it's amazing that it democratizes access for so many more people. But it doesn't take away from the fact that there's still a market for like a high value
Totally.
commodity, right? So in the example of AI, if you're Pfizer, you're a biotech company or a pharmaceutical company. What's a couple of $1 billion to get the latest and greatest top-notch protein synthesizing AI that can, or something that can detect cancer? To your point, they're not trying to save a couple of bucks. Like they'll go for the latest and greatest. But then maybe you and I are trying to come up with a cool thumbnail idea, or maybe a little, in the future when there's more multimodal stuff for video.
Yeah.
And if it's 93% or whatever the value is, it's probably good enough. And so really, I just think there's going to be a lot more people who can use it for varying tasks, and there's going to be a market for all of it. What do you see for the future of companies like NVIDIA, for example, that basically kind of are one of one when it comes to the hardware that backs the AI revolution?
So, in my opinion, there are going to be companies that need 99.9999% accuracy, right? So, what they're going to do is they're going to be demanding all of these new techniques that we just talked about, the memory management techniques, the floating point this, the mixture of experts model that, whatever, in whatever model they choose, because they're willing to spend top dollar, but now they should be demanding roughly, it seems, 25x more performance for that dollar, right? So it's not, I'm no longer going to buy NVIDIA GPUs. I don't think that's what's going to happen in the computing industry. They're going to say, hey, I'm going to buy the top of the line GPUs, but now what I expect out of them, I expect my returns much sooner, because now there's all these other things that can make me use far less GPUs or the same amount of GPUs and get far more out of them, right? So I don't think, when Mark Zuckerberg buys 500,000 H100s or whatever the total number is, he's like, wow, I just lost, 95% of my investment or whatever. He's like, I'm about to 75x my investment. I'm about to like figure all this stuff out, put it in Llama, and do the same thing over here, right? Likewise, I don't think OpenAI is going to sit still and be like, oh, I guess we're dead. They're going to be like, oh, okay, we can play all these tricks, and we should be able to lower our costs by about 25x, so we can release like a $2 subscription, or we can give people on the $20, the $200 plan, whatever it is, 25x more, right? And people should be demanding that. Just to be clear, the ultimate winner here should be the consumer, because
Right.
the consumer, just everybody knows now that you can do roughly the same thing according to the benchmarks for roughly 2.5 to 5% of the cost if all the numbers are to be believed, right? So I think what happens is people keep spending on compute, and there's a big bifurcation. Some people say, hey, I don't need to spend as much on compute because I have a performance limit that I need to hit, and I can hit it for way cheaper now. But I think the majority of big tech is about to squeeze a lot more out of their giant hardware investments. I think Stargate still happens. I think Stargate, whenever you see this kind of step function in performance, because just to be clear, I just want to be super clear for a non-technical audience, a step function in performance or cost are the same thing. If something becomes 25x cheaper to do the same thing, you can spend the same amount of money and you should be expecting 25x more, right? So one is just a lower cost, which is great for me who wants to spend $2 on OpenAI but not 20.
Right.
And one is an increase in performance for the people spending $500 billion to build a Stargate supercomputer. That Stargate supercomputer just got 25 times better.
The first question that I had when I started to look into DeepSeek is, if they had something so amazing, why open source it, especially coming from China? You would think, they're trying to compete. The U.S. is seen as the leader. This is a bit of an arms race. Why open source it?
So I just want to be clear. I'm not a political guy. I don't want to get into politics. I don't want to turn this into a political thing. In my opinion, what really happened is they open sourced it and released it on Donald Trump's inauguration day to show Donald Trump that, hey, we will innovate despite all of your export controls, all of your sanctions, etc. We don't need American chips. We can do this on a shoestring budget and perform with the best of the West for pennies on the dollar. And here it is with proof, technical papers, open source, have at it, your move. You know what I mean? China's known to act very symbolically, release things on very important dates to the West, do things that are very grand gestures. I would look at this akin to a military parade. It's here are a couple papers and a model that works flawlessly, and it's at the top of your app stores right now, and it's all open source. And we did it for a fraction of the price without your GPUs. That's how I would read that open sourcing.
I remember when I first started writing apps for the iPhone. I was working on this little space game, and I think we had 2 gigs of RAM in total for the entire phone, right? Or maybe around 2 gigs. So you can imagine the obsession we would take for everything. Like, what could we do to minimize our impact? And then new hardware, new phones have 16 gigs of RAM. I've heard of phones with 24 gigs of RAM. I mean, as some of that stuff changes, the necessity to be obsessive with every detail kind of diminishes, right? And it's interesting when the opposite happens. Like, if the next iPhone, the next Android phone came out with half or a quarter of the RAM, you'll maybe see more innovation than we're seeing now in terms of optimizations. It's interesting.
So, just to drive the point home, the Apollo 11 guidance computer had 4 kilobytes of RAM. So we went to the moon on 4 kilobytes of RAM. If we can go to the moon on 4 kilobytes of RAM, China can figure out how to do things with the H800s instead of the H100s. So I do think that a lot of these artificial constraints we place on certain countries, they just make no sense at a fundamental level. It takes 4 kilobytes to go to the moon. You know what I mean? Any constraint above that with any task less hard than that should be achievable, right? So what are we doing?
Yeah. So one thing I've been hearing about is something that Palantir, and I know you cover Palantir a lot on your channel as well, is that ultimately, this arms race, this happens for a lot of things. When the iPhone first came out, it felt novel, but 8 months later, the first Android phone was out, and now they're a commodity. I mean, with LLMs, we're probably heading the same direction. We're going to have so many NVIDIA, supercomputer clusters out there. We're going to be training so many models, specialty models for everything under the sun. Eventually, it'll probably be a commodity, and it depends what you build upon it. Like what you do with that ultimately will be what matters, not the LLM itself. I think everyone sees that AI is going to be incredibly disruptive, and they all want to be the ones that do it. So is this just the beginning of embargoes and all the kinds of things that we've been seeing?
I do believe that ultimately the models themselves will be commoditized. And I think DeepSeek is a very big step in that direction, because now the best model and the cheapest model, the gap between them is very small right now, right? That's the definition of commoditization. If you can get 99% of the performance of the best model for 1% of the cost, you're sitting on a commodity, right? But what the AI industry has known for a while that the market seems to be unable to digest is the foundational model is not, has never been, and will never be where the value is generated. It's all the stuff you build on top of that, like you were just saying, right? It's not about a model that can recognize images. It's about a medical imaging system that can recognize cancer in an X-ray, right? That's something you build on top of an image recognition model, which is largely commoditized. It's not about building a model that can solve fluid dynamics. It's about building a model that can accurately predict the weather months into the future instead of days. That's where the value is, right? So it's absolutely right to say, hey, the foundational model is a commodity. Where the real value in OpenAI is then, for example, is like they're trying to build agentic AIs, right? So it's a very capable foundational model, and now all of a sudden you allow it to take actions on your behalf. It can buy things, it can book trips, it can coordinate your schedule, it can send emails, it can do tasks that start affecting the real world, albeit in a digital way, right? Your digital footprint is really changing because of this agent acting on your behalf. Again, sending an email. Letting an agent send an email actually sounds pretty scary today, right? Like, that's not something you can undo. So you really want that agent to be really capable, really smart, really literate, and thoughtful. Maybe you even still want to make it give you final approvals over the emails. But like, we're heading in a direction where these AI agents are really taking actions on the behalf of physical people, actions with implications. Think about all the things you can do with one bad email to the wrong person, right? Or one bad financial transaction, or
Yeah.
et cetera, right? Okay, that is just one avenue. What about robots? Robots come in many shapes and sizes, right? So a big area of focus on building on these foundational models is taking tokens in, imagery, sensor data, radar, LiDAR, camera data, and instead of translating that into text or translating that into like a transformed image, you're transforming that into robotic behavior, robotic movement. The robot sees the world around it, in terms of LiDAR, radar, and camera data, and it behaves by walking through it, picking up objects, interacting with people, giving guidance, right? Whatever the robot is designed to do. That transformation from sensor data to robot locomotion and output, for lack of a better word, is incredibly hard. That's not a problem that's going to get solved by DeepSeek tomorrow, but it laid the foundation to do that faster, cheaper, better. Why? Because of all of the memory tricks we just talked about. They can apply to robots. They can apply to weather systems. They can apply to cancer screening systems. There's no reason that if we can read words in a compressed space, we can't read images in a compressed space. We can't look at videos in a compressed space. We can't understand fluid dynamics or proteins in a compressed space. So all of a sudden, these breakthroughs, my favorite thing about AI is when there's a breakthrough in one area, everyone figures out how to apply that breakthrough to all these other areas.
Right.
Fundamentally, we're still talking about neural networks, transformers, right? Like all of these big buzzwords that people talk about. When we talk about transformers, a transformer kind of is a transformer is a transformer is a transformer. There's all these different architectures and special things about it. But when somebody's like, I just made the transformer better, that's like saying you made the transistor better. It's like, you just changed phones, you just changed cameras, you just changed computers, you just changed space shuttles, right? Like everything the transistor touches just got better, right? So that's what's happening here. The real DeepSeek breakthrough isn't like, wow, LLMs just got cheaper. It's like, holy crap, we can do a lot more with a lot less memory than we thought. Where else can we apply this, right? Like, what does this mean for cancer screening? What does this mean for weather detection? What does this mean for robots, right? That's the real, like, where Wall Street is going to be focusing in a couple of weeks when they get over the cost difference between OpenAI and DeepSeek.
Okay. And the second part of that question was kind of the geopolitical component. Are we
Yeah.
just at the beginning of Um, I know you didn't want to get into politics. Let's talk about what do you think? No, I'm just kidding.
Yeah, yeah. No, I get it. I get it. Like,
But like, I mean, is this just the beginning, and are we going to see a lot more trade wars and you know?
yeah. So my thinking on this is hopefully DeepSeek proves that inflicting sanctions and stopping access of certain technologies to certain countries just makes them more innovative. The big lesson here is no matter what we do to try to get these chips out of China's hands, China is capable enough. I love this anecdote. China has more honor students than America has students, right? So it's like just by the law of large numbers, China can throw a lot of very smart people at these problems. You know what I mean? And these problems are solvable. We just talked about it takes 4 kilobytes of RAM to get to the moon. So this is a solvable problem, right? Like the bounds, they have much more than that amount of RAM, and the problem is much less hard than getting to the moon. And they have way more smart people to solve it. So maybe we need to take a step back and say, okay, this isn't the right avenue for defending ourselves. We need to out innovate. We need to invest in education. I don't know what the right answer is
Yeah.
personally, but what we're doing, I can point to what we're doing now in these DeepSeek papers and show you, hey, what we have been doing isn't necessarily working. You know, that's hopefully that's a good answer without getting political. You know,
Yeah.
I don't care which administration is inflicting these sanctions, but clearly this isn't the economic route isn't the right route to take, in my opinion, based on the evidence I'm observing.
Is there like a security concern, right? I mean, this is always what comes up. We literally just banned TikTok. I think it's back for 30 days, whatever the case might be. But it's
Yep.
the same component. It's the same thing. If you have this LLM sitting somewhere else that is, listening or not listening, but monitoring all your requests, what you're thinking about and stuff, is there a concern? Is it overblown? Is that something that we should be thinking about and worried about?
Yeah, so I think you just described a multi-billion dollar idea as an American comes along, takes DeepSeek, hosts it on American servers, guarantees no security concerns like that, right? Connects it through CrowdStrike or whatever, and says, "Here's DeepSeek, but it's on American servers with American security, validated by third-party American companies, otherwise identical to DeepSeek, still the same open source model." You're a trillionaire. Good job. Like
Yeah.
the inherent distrust of China taints this product for sure.
Yeah.
But that's why they open sourced it. Like this, that's why it's such a slap in the face to like American policymakers and whatever, is because they're not like, we have the best model, it's a black box. They're like, here's exactly how we did it. So nothing stops Meta, which, makes Llama, which is the best open source model in the West, is my understanding, from taking these techniques, incorporating them into Llama, and now we never worry about everything you just said because people really do inherently trust Llama, right? So,
Are you optimistic with the future of AI? Do you like how it's unfolding? I think it's kind of like the Pandora's box problem, right? The minute that lid starts opening and it just gets out there, it feels like plastic in the ocean. You're never going to capture it all. Like it just feels like it's kind of an unbound thing. So are you optimistic? Are we heading the right direction?
I have an optimistic disposition. As
I
like
do
a
too.
normal person, I tend to believe that people inherently try to create value. Whenever we have tools, yes, like, people learn to use tools for nefarious ways, but by and large, life always seems to be getting better. The quality of life, the quantity of life, the options we get to do, how much things cost. I know these last few years feel like things have gotten way more expensive because of inflation. Like things feel a little worse than they used to locally, like over the last 5 years. But if the grand scheme of human history, whenever we invent a new giant, largely applicable general set of technology, electricity, steam engine, internet, GPS, computing, now AI, life largely gets better is my personal view. I do have a concern about how fast things are progressing and how little emphasis and resources we're placing into AI alignment and AI safety. It seems like we have just thrown those words like out the window. We don't care. As soon as the model gets better, release it. Don't do any testing. I think Google at one point had their like AI overviews telling people to eat rocks and take the wrong medication. You know what I mean? Like
Yeah. Yeah, the
that
hallucinations.
part that I think, there needs to be some corporate responsibility for those kind of things. Sorry, the model had a bad output. I don't think is good enough. I think the owner of the model like should have liability. I am for here's another like relevant example. self-driving cars, level 3, the car is responsible, right? So like if a level 3 autonomous car gets into an accident, it's the automaker who's responsible, right? Just to be clear, not the driver, the
Right.
automaker, right? So I do think we want those kind of rules for AI, large language models, and those things too. When a model inevitably misdiagnoses cancer, is the hospital responsible, like as the owner of the model, or is the developer of the model responsible? Google, OpenAI, Llama, whatever it is. You know what I mean? So I do think there are going to be serious conversations around liability, responsibility, you know, new laws and regulations around those things. I hope those laws and regulations are around the outputs and their effects on people. So if a model kills somebody, the owner of the model should be charged for murder. Just like if I was in a car and I caused a wreck that ended a life, same thing, right? So I think if we get to a place where we can regulate outputs, you know, punish bad actors, not for using the tool, but for the crimes they commit as a result, then I think I'll be a lot more positive overall, not just because of my disposition, but because I see society actually taking the right actions to make sure that AI is bounded by the rules of society and doesn't somehow
Right.
get to escape it and live outside it. Does that make sense?
100%. We've talked about this before. We were together in Vegas for CES. 100%. That sounds very rational, and it sounds like that's the right thing to do. I've also voiced concerns about the creative components, right? We're using videos and art and paint, like human creations, to train some of this stuff, and it feels a little exploitative because of
Yeah.
some brilliant artist came along and had some brilliant stroke of the pen or brush. And then we're just commoditizing it and using it for training. That feels a little bit of a a false step, but yeah, I think some of these things will play out. This is the Wild West, right? When people came to California looking for gold, there was no OSHA, there was no requirement for 8 hour, 2 hour breaks every three. No, there was none of that. It
Yeah.
was just Wild West, right? And we're
Yeah.
there now. Ultimately, guardrails would go up, and some of that stuff would be more better honed. But that is kind of the nature of it. So then, last question: NVIDIA. The How are you feeling about NVIDIA today?
You know what? About 25 times better than I did last week, right? Because models just got 25 times more performant per dollar.
Yeah.
So I don't know, man. I'm excited about the future. I think we're living on the digital frontier. You know, the Wild West is a great example of the physical frontier. I think we're on one of the final frontiers, which is, you know, what happens when the intelligence generated on the internet is not only generated by humans. You know, it's a really exciting time. It's a really nerve-wracking time, but, you know, being in the thick of it, I think it's a real net positive. The amount of intelligence is growing every day, and, you know, that's pretty useful.
Yeah. Alex, ticker symbol you, thank you so much for joining us. Like I mentioned, I'll have a link to his video that he just aired today. You got to watch it. Fantastic deep dive into what this means. And thanks for making time today. I really appreciate it. This is kind of hot and new right now. I was thinking about it. I was like, what better person? So thank you so much for joining us. Appreciate you.
Dude, thanks for having me.
Thank you guys so much for watching. Until next week, we'll catch you guys later.